Alright, so we're beginning to learn how to do some calculations with solutions. Let's begin with some very simple problems here. Okay, let's take a look at this problem. If 1 gram of ammonium chloride is dissolved in 50 milliliters of water, and if the resulting volume of the solution remains the same as the solvent, that is to say the water volume, the stuff up here, I want to find the following. 1, let's find molar concentration. Let's remember that molar concentration, which is symbolized by the capital letter M with a line under it when it's being used as a unit of measurement. And a concentration unit of molarity, or molar concentration, is in moles of solute over liters of solution. So looking at the problem here, it says we have 1 gram of ammonium chloride. That's the solute, and we need it in moles. Well, we've been doing that for close to 2 months now. We've been converting grams into moles. So if we have 1 gram of ammonium chloride, and you need to know how to figure out what that formula is. Ammonium is a polyatomic ion that you have to memorize in this class. In other classes, you may look it up on a list that tells you what the ammonium ion's formula is, NH4+. The chloride ion, chlorine, the atom, is in column 7A or 17 of the periodic table, and it has a 1 negative charge when it's combined like this. So 1 plus 1 negative, you get 1 of each. Put that over 1, multiply by the inverse of the molar mass. You have to calculate the molar mass for ammonium chloride, and I'm not going to show you how to calculate molar mass. We've been doing that a long time. What I'm going to show you is what the molar mass is, and it's 53.49 grams NH4Cl. And on the top of that goes the moles, 1 mole of NH4Cl. So when you calculate molar mass in my class, you're required to write it in the form of an equality statement, where we put one side of the equality statement on the bottom, one on the top, so that the value of this the value of this conversion unit is equal to 1. That's why we call it a conversion unit. So we do the math. We cancel out units. We're going to cancel grams. We're going to cancel ammonium chloride. We're going to cancel the species there. The ammonium chloride is the species. And the math shows us we have 0.01695083193. You can write as many digits as your calculator shows. Your calculator may not show as many digits as mine does, but this is moles. Going to round to the correct number of significant digits. This number here has the least digits. We want the final answer to have that number of digits. Leading zeros are not significant, so our first significant digit is 1, 1, 2, 3. Underline these to show we're rounding those off. Draw an arrow. We get 0.0187 moles of ammonium chloride. So we have what we need on the top. Now we need to find what we need on the bottom. We have milliliters of water, which we said is going to be the same volume. We'll have the same volume as the solution. We want liters of solution on the bottom. So all we have to do is convert this into liters, and we'll have liters of solution. We know that 50.0 milliliters of the solution here, in this case water, has the same volume. It's going to be converted using a ratio here where 1,000 milliliters equals 1 liter. So we have an equality statement. I haven't written the equality statement. On a test or quiz in my class it's required, but we can cancel out milliliters. Dimensional analysis then shows us we're going to have liters of solution, and we do the math, and we get 0.0500 liters of solution. So we have 3 significant digits here. Leading zeros are not significant. 3 significant digits in the final answer. We don't use this for figuring out significant digits because these two numbers, this is an absolute ratio. Those are infinitely significant. So this is our volume of the solution. So we can put the two together now. 0.0187 moles of the solute NH4Cl over 0.0500 liters of NH4Cl solution. And so we've got moles of solute over liters of solution here. And that'll give us the correct molar concentration 0.374 molar NH4Cl solution. SOLN is just a shorthand way of writing solution. And so there's our answer. All right, let's find the second question, the answer to the second question. The second question says we're going to find the molar concentration. Molar concentration is moles of solute over a liter, or rather kilograms of solution, moles of solute over kilograms of solvent, rather. So molar concentration is moles of solute over kilograms of solvent. So to solve this problem then, we already have the moles of solute in the last problem. We found that it was 0.0817 moles. So we have 0.0187 moles of ammonium chloride. That's the part that goes in the top. The solvent is water in the problem, and we have 50 milliliters of water. So we've got to get the milliliters of water, 50.0 milliliters of water, which is our solvent, into kilograms. First we're going to convert it to grams. You need to know the density of water. It's something you're supposed to memorize. We brought it up, I think, in Unit 2 in this class. Is about 1.00 grams for every milliliter. So we can convert this into grams then, putting that over 1. We're going to put 1.00 grams of water over 1 milliliter of water. Milliliters cancel, water cancels, and we have 50.0 grams of water. Let me just write that as H2O. Still got to convert it to kilograms. You know, there are 1,000 grams in 1 kilogram. So there's an equality statement. We'll take this 50 grams, put it over 1, use this equality statement here. We're going to match the units and species, or in this case just the units. The number with the same units will go on the bottom because same units is the starting amount here. So 1,000 grams goes on the bottom because I have grams over here on the top. Kilograms are going to go on the top. Then when we cancel the units, we're going to be left with kilograms of water. 0.0500 kilograms of water. That's our solvent mass in kilograms. So the molar concentration then is going to be moles. 0.0187 moles NH4Cl over 0.0500 kilograms of water. And we're going to get 0.374 molar. Molar concentration is moles over kilograms. Moles over kilograms. Molar NH4Cl solution. They need to be careful. I know that in this case, the molar concentration was the same as the molar concentration. That will not always work out that way. So be very careful not to make that assumption. In this case, because of the way I set it up, it did turn out to be the same. And they will be rather close, but they won't be exactly the same sometimes. All right. We're going to find percent concentration now. That's our last problem. Find the percent concentration. And percent concentration puts the mass of the solute over the mass of solution. Mass of the solute over the mass of solute plus solvent is the same thing because solution is solute and solvent together. In this case, we're going to need to use this second one. In the problem, we have the mass of the solute, 1 gram of ammonium chloride. We can put that on the top. The mass of the solute is the mass of the water. That's the mass of the same thing. It's the mass of the ammonium chloride. So we've got 1.00 grams of NH4Cl. The mass of the solvent is the mass of the water, And we already found that the mass of the water was going to be 0.0500 kilograms, or 50 grams. That's what we started with here. We found the mass of the water. So we already know the water's mass is 50 grams. So we're going to add the mass of the solvent, which is water, plus 50.0 grams of H2O. And then the whole thing gets multiplied by 100. And we do the math. We get 1.960784 31373%. Going to round that off to the correct number of significant digits. We've got 3 significant digits in all 3 of these numbers. So we want 3 significant digits here, 1, 2, 3, underline everything else, draw an arrow to show a rounding off, and we get a percent of 1.96% ammonium chloride. If you don't state that the percent is some other units of measurement or some other comparison, it's always assumed, because it says so here, that percent concentration is going to be the solute in water. Okay? So that's an assumption. If I don't state that it's ammonium chloride in water, then the assumption always is that it's in water. If you just say percent ammonium chloride, then the reader should assume that's the percent of ammonium chloride in water, and so writing it just this way is perfectly okay. And that's how we find the solution to those kinds of problems.